Okay, dreaded properties. Continuing on with the algebra review for the exam. Remember that you want to compare the left side to the right side. What happened here is that the 2 was multiplied by each term. That's called distributive property. There's a longer name for it, distributive property of multiplication over addition, but distributive property is sufficient. Looking at number 42, what happened from the left side of the equal sign to the right side? Well, it looks like the order changed. And remember, when it's dealing with order, we're talking about the commutative property, and that would be of addition. Number 43, what changed? Well, it's not the order this time. You'll see that 50, 17, and 2 are all in the same order. What changed is what's in the parentheses. So you'll see that 50 times 17 was grouped on the left side, but on the right side it was the 17 and 2. So this is a grouping, and the property that deals with grouping is the associative property, and we were talking about multiplication. And this last one, what we're doing here is adding 0, which means that's the additive identity. Oops, identity. Learn how to spell. Okay, so you could either say identity of addition or additive identity, however you want to do that, but anytime you add 0 to get the same number, that would be called the identity of addition. Okay, now we're going to solve the inequality, write the solution based on the given information, and then graph on a number line. Sometimes we only need 2 out of the 3 of these answers, and I'll go over when you need 2 and when you need all 3. Natural numbers. The first thing you need to remember is that natural numbers are the set of numbers of the counting numbers, 1, 2, 3, etc. That's just a little reminder, okay? So now let's do the problem. The first step of the problem remains the same regardless of what you're solving for. Get the y by itself. You do that the exact same as if it were an equal sign, with one exception. If you multiply or divide by a negative number, you flip the direction of the inequality. So here I'm going to bring down the 5y. I'm going to add the negative 5 plus 20 to get 15. I divide by 5. I'm not dividing by a negative, so I do not flip the inequality, and 15 divided by 5 is 3. There is the solution, step 1. Now you need to graph it on a number line. So pick the number in question here, and then put a few numbers on each side. So 2, 1, 0, negative 1, 4, 5, 6, 7, 8. All right, so in the set of natural numbers, okay, which numbers are less than 3? Well, remember, the natural numbers are just the counting numbers, 1, 2, 3, 4, etc. No fractions, no decimals, no negative, no 0. So the only numbers less than 3 are the numbers 1 and 2. So you would put dots on those two values. And when you do your solution set, which you do for natural numbers, you just write the numbers that have dots on them, 1 and 2. They're not going to keep going in this direction because natural numbers don't include 0 or negatives, and we don't keep going in this direction because those numbers aren't less than 3, so you wouldn't have any dots anywhere. So this is the solution, this is the number line, and this is the solution set. And you do solution sets for all problems except when dealing with real numbers or well, that's the only one. Just real numbers doesn't use a solution set. Okay? Speaking of real numbers, here's the first problem. Remember that real numbers do include every number that you know of at this point. That means all fractions, all decimals, all negatives, all positives, and 0. Step 1 remains the same. Solve for x. So I want to subtract 12 from both sides. Bring down the negative 4x, bring down the less than. Negative 12 minus 12 is negative 24. Divide by negative 4. Remember, I told you that when you multiply or divide by a negative, we flip the direction. So since I'm dividing by a negative 4, I change that to greater than, and then negative 24 divided by negative 4 is positive 6. That's the solution. Now I need a number line. So I'll put 6 in the center, and I'll put a few numbers on each side. Okay, x greater than 6. With real numbers, when you have the set of real numbers, is the only time you're going to use an open or closed circle. All of the others you will use closed circles. When there is no equal sign underneath the inequality symbol, it will be an open circle in the set of real numbers. So around the 6, I will put an open circle. That means that the actual number 6 is not included as part of the solution, but everything up to 6 will be. And now with real numbers, again, this is the only one where you actually shade. So we're going to shade which side of this number line. Well, where are the numbers greater than 6? Well, that would be to the right, so I'm going to shade all of these numbers and darken the arrow to indicate that it keeps going and going and going. And because real numbers include all these decimals and fractions and all that, there's no way we could write them in a solution set, so a solution set is not required for the set of real numbers. Okay, let's solve this problem for the set of whole numbers. First thing you need to do is remember that whole numbers are the numbers 0, 1, 2, 3, etc. No fractions, no decimals, no negatives. But the difference between whole numbers and natural numbers is that it does include the number 0. So we want to solve this problem like we normally would. That means we want to bring the variable to the left by subtracting 6x. So I get negative 10 minus 1x less than or equal to 16. Numbers to the right by adding 10. Negative 1x less than or equal to 26. Divide by negative 1. And x, remember that when you divide by a negative, you flip the direction of the inequality to be greater than or equal to negative 26. Now this is a tricky problem, and I won't do that necessarily on your exam, but you do need to be aware. Remember that we said the set of whole numbers starts at the number 0. So when we're going to graph this problem, we can't possibly put all of these numbers. So I'm just going to put like negative 50, negative 100, and they're not equidistant or anything. I'm just trying to put some numbers on the number line so we can see what numbers are where. Okay? So whole numbers. Well, whole numbers are all of the numbers. I probably shouldn't use 25 here. We do need to use 1, 2, etc. So what is the first whole number that's greater than or equal to negative 26? Well, 0 is greater than or equal to negative 26, and it is the first whole number. So the first whole number you would put a dot at is 0. And then, of course, 1, 2, and then keep going and going and going. Okay, so none of the negatives, but you would start at 0. So your solution set here happens to just be the entire set of whole numbers. And it does keep going and going and going in this direction because it is all of those numbers that are greater than negative 26.